We present first-person view hand segmentation of multimodal hand activity video dataset. First-person view videos of hands interacting with tools are widely used in the computer vision industry. However, creating a dataset with pixel-wise segmentation of hands is challenging, especially in hand with object cases. The boundary of fingers and objects creates many holes and curves. Conventionally, creating pixel-wise segmentation is done by manually drawing polygons, such as Microsoft's Common Objects in Context, Amazon Turk Segmentation API, PolyRNN++, etc. The major drawback of this method is that polygons can't define smooth curves, not like our method. How to label smooth curves and holes at pixel level. To relieve challenges, we propose a method that utilizes thermal information of hands for efficient pixel-wise hand segmentation to create a multimodal activity video dataset. Our method is not affected by fingertip and joint occlusions and does not require hand pose ground truth. With the segmentation method, we propose a multimodal hand activity video dataset with 790 sequences and 401,765 frames of hands using tools videos captured by thermal and RGB-D cameras with hand segmentation data. Compared to the other existing hand segmentation datasets, our dataset contains 3 different modalities and inertial measurement unit information of the head-mounted camera. The video dataset contains 5 subjects, 15 actions, and 23 tools. As shown in the qualitative comparison of manually annotated images with polyRNN++ against our method shows much more accurate and smooth curves. We analyze the effect of multimodal sequences for hand segmentation by conducting 7 ablation studies using all possible combinations of thermal, RGB, and depth information. To validate the performance of using multiple modalities, we compare our method with 5 state-of-the-art segmentation methods. Deep Lab version 3 Plus with 3 modalities outperforms other methods. Thank you.